Hey RJ, Emma. Hey, I looked at your test. I thought you guys did pretty well. A couple of things I wanted to talk about. Number 16, I went ahead and omitted it from the test, but I want to be real clear with you. It's going to be on the next review and as well as the next test because I do think it's a concept we need to have. It just seemed like all three of you guys struggle with that just a little bit. I want to talk, if you look at your test, number 16 talked about them going uphill or upstream and downstream. And I want to get the concept. So downstream means that you're going to go at a certain rate, and then you're also going to have a current. So in other words, you'll have a rate which you typically go like in still water, but then downstream means you're going to go with the current. If I'm going to go upstream, I'm going to have that certain rate, but then my current is going to be pulling me back. So it's going to be that I'm going to have to subtract my current. Now the formula that I really need you to understand is that distance is equal to rate times time. And in this case, we know what our distance is, and we were given a rate. We were given a rate, but we don't know our time. And so when I set up my equation, I'm going to go ahead and I'm going to let my variable x equal the time that they're going to spend. Now I know that if I set it equal to my distance that they're going to go, and remember if it said that they're going to go downstream for 3 miles, they're also going to go upstream for 3 miles. So let's start off with just the equation for downstream. And so in this case, I know my distance was going to equal 3, but then I have two rates that I'm working on. So in other words, I'm going to take, to find my rate, if she's going to go 2.2 in still water, and to find out how much time it's going to take, I need to multiply that so that I have my rate times my time. But then I'm also going to have a current. And so in this case, they said the current was 0.2. And so that's where I'll also have 0.2 times x, or 0.2, which we're going to talk about a little bit more today. And when we solve this equation, I'll end up taking 2.2 plus 2.2 and then times x. So this will be then 2.4x is equal to 3. And then I have an equation I can solve. So I'll divide both sides by 2.4. And I believe you come up with then by taking 3 divided by 2.4, you'll get the 1.25 that I was looking for. And again, that's going to be your time, so that's going to be in hours, since your rate was in hours or miles per hour, and then the 3 was the miles. Now upstream, goodness, I can't talk. Let me just do the U.S. because I can't seem to spell today. So remember, I'm going to subtract my current. So I know that I'm going to go 2.2 is my rate times my time. So that's going to be my x again. But this time I'm going against the current. So I'm going to subtract 0.2x. And then that is going to equal then my distance. In this case, it's going to be again 3. So in this case, I'll have 2.2x minus 0.2x. That's going to be 2.0x. or just 2x is equal to 3, and therefore x is going to equal 1.5 hours. The other thing that I really wanted to kind of hit on was number 18 and 20 with you guys. And I feel like it might be part of it, the issue is with your calculator. And I want to make sure we understand, like on this one, if I have f of, and it seemed like the negative numbers were giving us a little problem. Say that I had f of x is equal to x squared, 3x squared minus 2x. Now what that means is that when I do the 3 and I put the negative 2 in for my x, I will square that and then subtract 2. Now watch, if I were to take my calculator and I just go the same, and I notice I have, I think it was, let's go 3 times, and then I'm going to go minus 2 and square. What this means is that it's not going to take into account, it's going to actually take 2 squared, making it 4, make that negative, and then taking it times 3. If you want to truly get this right with your calculator, you're going to have to go 3 times and then parentheses -2 close parentheses squared, because then I'll end up then with a positive 12, because when I square the negative, that means that I'm having -2 times a -2, that makes it 4, and so my final answer would be 12. Actually, and it'll work the same way if I put a positive number in there because I'm squaring that. So I want to make sure we're kind of clear on that. I noticed on number 20 that was kind of the same issue. In 20, you were asked to evaluate your given equation. So in this one we have f of x is equal to x squared minus 3. And whenever I put a negative number into that, remember I've got to make sure it's in parentheses because I'm going to start off with a -3 expression squared minus 3. If you go minus 3 squared minus 3 in your calculator, you will not get the correct answer. Okay, the correct answer would be substitute the -3 in there. You can put it in parentheses, then square it in minus 3, but your answer should be then 6. And the reason is you're squaring the negative, so -3 squared is going to be a positive 9, and then you're going to subtract 3 is equal to then 6. If you do it the other way, what it's doing is that it's like this. It's -3 squared minus 3. Well, they're going to first take and square just the 3 and then make it negative. And so the incorrect way would be the -9 minus 3. And so keep in mind, you've got to be careful when you substitute those in, especially if you're relying a lot on your calculator and not kind of your common knowledge of what you're doing. So other than that, I thought the test went well. Email me any questions or any concerns. You have the key. If you think that I incorrectly graded something, then shoot me an email. Today we're going to talk about 9-1, and then I'll have that as part of your lesson. You'll be able to do that on the computer. But today we're going to talk about the conversions. So we're going to work on changing units of measurement, and today we're going to start really with just linear. And so linear is going to be again the measurement, that how long something is, and it's one dimension. We're going to be getting into the 2 dimension, like the area and the volume, but we're not doing that just yet. We'll do that on next week. But converting those, our book will use a unit fraction. I typically sometimes will say a unit multiplier. It means the same thing. I've also heard other classes using as unit conversions. But the unit is the key part. The unit means that it has a value of 1. So for instance, if I have 12 inches over 1 foot, those are the same amount. That's the same linear amount, and therefore it has a unit. It has a value of 1. 1 foot to 12 inches. Remember, we can flip those, and I'll show you how we need to have some of them on the inches on top, and sometimes when the inches then are on the bottom. But any of these linear units can be written as a unit converter or unit fraction. And then we will be also using that same thing when we get into the metric. So today, let's just jump in. If I were to go ahead and I want to convert 40 inches to feet, what I will tell you until we get comfortable, I like to have them start off with 40 inches. So what you're given, you put 40 inches, and then you put it over 1. All right. Then, if I'm going to convert inches to feet, that means that my inches will need to be canceled. So if it's on the top, it'll have to be on the bottom. And then I'm going to change it to feet. And so I'm going to put feet on the top. In this case, then that's when I'm going to look to see where my numbers go. And so in this case, 1 foot will equal then 12 inches, and therefore 12 is going to be on the bottom of my fraction. That's going to indicate that I'm going to divide. And so then I'll just, I need to then take 40 divided by 12, and I get then the 3.3 with repeat. And then notice the one thing that's left is feet. and that'll be my answer. If I have 13,200 feet and I want to change it to miles, I'm going to start by putting it over 1. I'm going to go from feet to miles, so that means that feet, if it's on the top, it's now going to be on the bottom, and then miles are going to be on the top, LES. And there are 5,280 feet for every 1 mile, so put a 1 and then 5,280. And this will indicate that I'm going to again divide. So I'll have the 13,200 divided by my 5,280. And then my answer then will be then 2.5. And notice what's left is going to be miles. If I have 21 yards over 1, and I'm going to go to inches. Now you can do 1 unit multiplier if you know the conversion, how many inches are in a yard. You can also do it with 2, and I'm going to show you the 2. But again, if you already know that you can simplify it by just doing 1 unit multiplier and going from yards to inches. But the first thing, yards will have to be on the bottom, and then the next one that I'm given would be like feet. So in other words, I have for 1 yard, every 1 yard there are 3 feet. Then on the next one, I know that since my yards canceled out, now I've got to change my feet to my inches. So I'll have feet on the bottom, inches on the top, and in this case there's for every 1 foot there are 12 inches. And so then the last step would be, since they're all in the numerator, notice on the earlier problems we had 1 in the numerator, 1 in the denominator, so we divided. In this case now, since they're all in the numerator, we're just going to multiply those together. So 21 times 3 times 12. And that will give me then 756 inches, because everything else cancels with inches. All right, going as if I had 21 inches and I wanted to go to yards. Okay, so this time again, inches are going to be now on the bottom because I want them to cancel. And so then I'm going to change, I'm going to go ahead and say I know that there are 36 inches is equal to 1 yard. And you could have done that also with this problem here. But in this case, I'm going to go ahead and use that information to solve this one. So in this case, I'm going to have inches on the bottom, and I have yards on the top. And I'm going to have, remember, 1 yard is going to be the same as 36 inches. And notice on this case that there are one's in the numerator, one's in the denominator. So therefore, I'm going to go 21 divided by then 36. As I multiplied it, divided by 36. And I'll end up with then a fraction. So again, depending on how you'll either round or you can leave it as 21 over 36. As long as you simplify it, notice that 3 goes into both, so that would be 7 over 12. And then you always want to finish your problem with the units that you're converting it to. The next section will be converting metric units. And I'm going to I give you an acronym starting with the largest and going down. So an acronym to help you remember the order from larger to smallest would be King Henry, so K and H, died, drinking chocolate milk. And so that will give you the kilograms, the kilometers, hectometers, decameters. In the middle is, I've also heard the same acronym, King Henry died by, and the B would be the base, and because in this case this will apply to meters, but you will also have liters, and so that would have the same kilo, hecta, deca, the prefix, deci, centimeters, and millimeters. Now what happens is that the metric system allows it to be easier to convert because you have to move the decimal. I'm also going to attach just a funny clip that I always like to show my kids. I usually try and show it the first of the class, but I'm just going to add it onto that, and it's from a comedian that's kind of mocking our metric and our linear system. So that one's just for fun. But let's go ahead and jump into doing some problems. So when I'm converting metric, so if I start off with the same idea, so I have 504.7 meters, and I'll just go ahead and use M. I'm going to start with it over 1. Now I'm going to go ahead and jump to kilometers. Now in this case, you see that from a meter into kilometer, there are then 3 skips. So that means that there are 1,000 meters for every 1 kilometer. And so in this case, my meters are on the top. That means they have to go on the bottom. And that means my kilometers have to go on the top. And then I'll cancel and I'll also add. So if I have that, if I know that for every 1 kilometer there's 1,000 meters, then I know that I'm going to divide. Well, the nice thing about dividing, I don't even have to get my calculator out like I did earlier. I can just move my decimal place over 3 places. And again, when you divide by 1,000, there are 3 zeros, and therefore move over 3 places. So I will have my answer is 0.5047, and it'll be kilometers. And the next one, if I have 27 meters over 1, and I'm converting it to centimeters. So again, if I look up my on the sheet, notice they're going to be larger. The largest just starts to the left and it goes down. So I have to go 2 steps to get to from my centimeters. So therefore, I know that 1 meter is equal to 100 centimeters. In this case, then I would know that meters are going to go on the bottom. So I'm going to put meters here. I'm going to have centimeters on top, and I'm going to have 1 meter for every 100 centimeters. Therefore, I'm going to multiply these together. That means I'm going to take 27, and I'm going to move my decimal place then 2 places, making it a larger number. So my answer is going to be 2,700 centimeters. The hectometers are a little less common, but 8.64 hectometers to centimeters. So I'm going to look again. I'm going to get a unit conversion. So here's my hectometer to centimeters. So again, hectometer is going to be larger. I'm going to have 1, 2, 3, 4 jumps. So that means that 1 hectometer will equal then 1 with 4 zeros behind it, or 10,000 centimeters. So when I do this problem, I'm going to have the hectometers, they'll go on the bottom, centimeters at the top, and I know that I'm going to put my 10,000 right there. So that means I'm going to start with 8.64. I'm moving my decimal to the right because I'm multiplying it by that instead of dividing. So I'm going to go 1, 2, 3, 4. I'm going to add a couple of zeros. And so my answer will be then the 86400 and my comma. So 86,400 centimeters. When you do this decameters to kilometers, and so remember you have the dA and you have the D. So in this case I would find out how many steps I have to go. So I'm going to end up going there for 1 kilometer will equal then 1, 2, 3, 4 decameters, dm. And so again, I'll start with 71 decameters over 1. My decameters are going to go ahead and go on the bottom, and that means my kilometers are going to go on the top. And in this case, I've got the divided by the 10,000 because I have 1 kilometer is going to be the same as 10 decameters. And then I'll finish that. Some of the units going back and forth, I typically I've only memorized this one, which is the 2.54. You can still use these other unit multipliers, and I can show you real quickly how, but even when I'd have to do something kind of large like this, I actually kind of bring it down to centimeters and meters, and then I move it back on up. Let me show you both ways real fast. So I have 125 miles over 1. If I'm going to go ahead and convert it to kilometers, I can go ahead and just use this acronym. So in other words, my miles, I'll go on the bottom, and my kilometers will be on the top. And notice that I'll have the 1.6 kilometers for every 1 mile. And I put minutes, sorry, MLE. Okay, so these will cancel, and then I'm going to just now I'll have 125. 125 times 1.6, and that'll be then the 200 kilometers. Since I've memorized this one, sometimes I could look it up, but in my head, if I were on a test and I had to do something like this, and I've memorized only this one, you can actually bring it down. So I'd have miles here, and I would have then feet. So I know that there are 5,280 feet in 1 mile. And then I would go then feet to inches. And so I'd have then 12 inches over 1 foot. But then I'd also go the inches here and the centimeters. And then that's the 2.54 centimeters over 1 inch. And then I would go from my centimeters to my meters. And I would have 100 is to 1. And then I would have then my meters to kilometers, and I would have 1,000. So if you look, really, I'm going to base it. I'll show you. I have 125 times 5,280 times 12 times 2.54, and then I will end up then dividing it by the 1, 2, 3, 4. And notice I'm getting something that's close, but if you notice, it's not exact from what I had before, and the reason is I thought I was going to get 2. What did I do wrong? Oh, meters. There are 1,000 meters. Let me go back and I will rework this one, and I'll put in the start of my lesson next one. So I'm not sure what's going on, but I'm off a decimal place or 2. I must have added in. Looks like 1, 2, 3, 4, 5, 6, 7. Oh, that's the problem. 1, 2, 3, 4, 5. So I would have gotten 201 if I had put the right number in. So I ended up with 201.1. And the reason that it's different is that it's going to be then just the approximations, because once we get into these values, that you're always going to have approximately a different amount. And so usually your computer problems will convert, and obviously I would accept either way when you did your test, as long as you show your work, whatever makes more sense to you. So the last one, converting millimeters to inches. So I'm going to start with 26,800 millimeters over 1, and I'm going to now go to inches. And so the first thing I'm going to do is go ahead and take my millimeters into centimeters, because that would be a conversion that I would know. So I know that there are 10, back to my metric. If I'm going to go from here to here, there are 10 millimeters in 1 centimeter, because there's just one jump. So I would have that, and then I would go ahead and start my centimeters to inches, and I know that there are 2.54 centimeters for every 1 inch. And then to finish it, I would just need to make sure I'm dividing. Now be careful on this one. If I go 26,800, if I divide by 10 and then divide by 2.54, I'm going to get an answer that's a little different. So what I would do is I would say you would have to, if I put it in parentheses, or I would multiply these out, and this would be then 25.4. So 26,800 divided by 25.4.4, which is 2.5 times 10. And notice, in this case, it does work. So anyway, be careful with your calculator. This one did it from left to right, so we were right. That's why it worked. It went ahead and did the 10 and then it did the 2.54. The last thing, let's go ahead and example the 8 yards to centimeters, and again you're going to start off with 8 yards over 1. I'm going to put yards on the bottom, and I'm going to have then, I'm going to go ahead and go to inches because I know that there are 36 inches in 1 yard. And then I'm going to go ahead and convert my inches on the bottom, it's centimeters at the top, and it'll be the 2.54. And so in this case, I'll just go ahead and multiply straight across. The next lesson will be, this will be due next week, so let me see, we'll see how we do.